Okay, we're going to talk about simplifying radicals or
Make
square
sure it
roots.
doesn't go into sleep mode at the really end.
Yes, don't. You stay. Okay. All right.
Is it asleep?
So radicals and square roots are the same thing. And to be honest with you, I don't know why they have different names. There's probably a great reason. I just don't know it. I haven't really had this burning curiosity to go study that and figure that out. But I know how to do them, right?
Yeah.
So that's really kind of an important part, is knowing how to do them. Now, you guys, most of you know them. Now, I don't know, some of you might not, because some of you might not have been exposed to square roots. Square roots. So we're going to start very simple. The square root of 1 is 1.
Whoa.
The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root, we'll stop on this one, of 25 is 5. All right, so now most of you probably knew that.
Yes, I do.
But some of you might not. And my guess is some of you didn't know that. And square root is what they're asking when they put, this is called a square root sign or a radical sign, okay? And what they mean when they put that is this is what they're saying.
I just realized that it's 3 away and 5, like 1 to 4 is, and there's 3 in between, and then 4 to 9 there's 5 in between, and then 9 to 16 there's 7 in between, and 16 to 25 there's
So
9 in
interesting.
between.
It's funny because just yesterday I was working with somebody and they said, is there a pattern to this? And I said, you know, I know there is, I just don't know what it is. And we just found it. That's great. I said if we sat here for 10 minutes and played with it, we'd probably figure out the pattern. That's pretty cool. When you put the square root sign over a number, basically it's saying what number times itself or squared equals
That number.
that
The number that's in
the number in under this radical sign. The number, is that showing up still? Okay, better stop there. The number under the radical sign. I'm making that very long. Right? It's easier than that. But what number times itself equals that number? Right? That's what it's saying. So, what number times itself equals 1? 1 times 1 is 1. Oh yeah, there. Oh, that's the answer. 1 is it. All right, now I'm going to look at this one. What am I covering up? What?
Make
Sorry.
sure
All right.
make sure it's
So
not sleeping.
sorry, but for this one, 2. What number? I mean 4. What the square root of 4? The square root simply says what number times itself equals 4. And so they're not actually that hard to figure out because it's got to either be 1 times 1, or 2 times 2, or 3 times 3, or 4 times 4, or 5 times 5, or 6 times 6, or 7 times 7. I guess it could be 1.5 times 1.5, right? If we were going to get complicated. But most of the time, what I'm going to be asking you to do is work only with whole numbers, right?
Some ones that are like the perfect squares.
And yes, if I used there are ones like if I said what's the square root of 5?
You'd be like,
Or 2.
Or 2, right? There's not a number. There's not a whole number that multiplied times itself equals 5. Now I could get out my calculator and I could see the square root of 2 is equal to 1 point something something, right? But they never end. A lot of those the decimals are never ending. So they would go on forever. So you'd have to just round it.
decimals.
You love what?
Never ending decimals.
Do you really? Cool. All right. So again, what number times itself equals 9? 3. What number times itself equals 16? 4. What number times itself equals 25? 5. That's all it is. It's really quite simple.
Should I like the whole
Right?
lecture?
No, that's the first part. That's the easy part. Okay? Now, I'm going to also ask you, we're also going to talk about what is a perfect square.
Oh.
Because I'm going to use that term a lot when we're talking about radicals. Does anybody know? Yes, what is it?
Like the shape?
Yes.
Well, all the sides are the same length.
Okay.
No.
So perfect square. So I'm gonna just write this down. Perfect square. Perfect square. Okay. So I've got all the sides are exactly the same length. Look at that beautiful perfect square.
Isn't that just a regular square? Isn't that the definition of a square? Is all the sides are the same length?
Yes.
Can't have a square.
All right. But I'm using the word perfect for more than that. Okay, yes, it's a square, and all the sides are the same length. But when I say perfect,
Oh.
do you know what I mean?
Yeah, it's like a number that when it's square rooted, it's a whole number. Its result is a whole number.
Yes.
Yeah.
So the sides are actually whole numbers, right? So like, watch this. If I said this side was 2, that means since it's a square, this side is 2, right? What is the area of this square?
4.
How'd you get that?
2 times
2 times 2, right? So the area is 4. Look at that. So
And the square root.
the square root of the area is one of the sides of a square. Isn't that cool? So if I had it, so that's true for 2s. I could do, if this were, I could have done,
3.
make it a little bigger,
5, 6,
right? I'll make it a little bigger, and we'll say this one is 5, and this is 5, right? And the area of this is 25. So the square root of 25
5.
is one of its sides, right? So it's the areas that are perfect square numbers. They're perfect squares. It's the areas. So 1 times 1 is equal to 1. 1 is a perfect square.
But could you have a?
Because I can have 1 times 1.
Could you have a square that? Oh yeah. Okay, good.
So I can take any, I can do 2 times 2 is 4. 4 is a perfect square. 3 times 3, 9. 9 is a perfect square. 4 times 4, 16. 16 is a perfect square. 5 times 5, 25. 25 is a perfect square. 6 times 6, 36. 36 is a perfect square. 7 times 7, 49 is a perfect square. 8 times 8, 64 is a perfect square. Right? I can have 64. 8 and 8, right? 9 times 9, 81 is a perfect square. 10 times 10, 100. 100 is a perfect square. Usually you don't have to go above that, right? Sometimes you do, but usually you don't, right?
Yeah,
You could,
it was like 100, 900, million, 100.
yeah, right. So
That'd be
there's
terrible.
it goes on forever and ever. There's an infinite number of perfect squares, but
Go
so
erase that line, Gary.
so go erase what?
That green line over there.
Oh, thank you. Okay, so well, just remind me. Okay, don't go past that. Okay, so what time do we have? We're okay. So sometimes what I do is off to the side of my paper when I'm doing radicals, when I'm simplifying radicals, I'm going to write down a list of my perfect squares.
Wait, is it
And
color
one, I don't, even though one is a
Over
perfect
there.
square,
You have a list.
you guys listening to this? Even though one is a perfect square, I don't use 1 when I list my perfect squares. Because usually if 1 doesn't change much, right? When you're simplifying, oh my God, I can divide that by 1.
I can.
And then,
multiply by 1.
I've got 6. I'm going to divide it by 1 and I get 6. And that
Oh my
6 is
God.
divisible by 1. And so I can divide that by 1 and I get 6. And then that 6 is divided. I mean, you could be doing this a long time, right? So it doesn't really, 1 doesn't work so well, right? So I'm not going to start with 1. I'm going to start with 2 times 2 is.
Don't you have a list right there?
So, yes, but I'm going to write them like this. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25.
36.
6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64.
4.
Where was I? 9 times 9 is 81. And 100, right? And I don't usually go past that. I usually just stop there. Most of the time, all you need are these 4. All right. Every now and then you'll need this and this and this, but very seldom. And you'll see what I'm talking about in a second. These all, when I take the square root of a perfect square, I get a perfect answer, right?
Perfect.
I get a perfect answer. It's a nice whole number, and it's easy, and it's wonderful. Now we're going to talk about numbers that are not perfect squares. And we're going to talk about simplifying them with radicals. Okay? So let's say I gave you this. What is the, let's say I said this. Actually, let me redo this. Let's say I said simplify, because we're really not doing anything other than simplifying here. Simplify the square root of 12.
Oh.
The square root of 12. Now, what are all the factors? What are different ways I could get 12?
4 times 3.
I could do 4 times 3. What else?
4 times 6.
2 times 6. What else? 3 times 4. What
12
else?
times 1.
12 times 1, right? I could do all of those, right?
Yeah.
And so I could do that. So there's one thing that I've got to just sort of preface. I just got to show you. The square root of 12 is equal to the square root of 2 times 6, right? You guys, that's pretty obvious, right?
Yeah.
And that is equal to the square root of 2 times the square root of 6. So I can actually split them up into 2 separate radical signs, but still keep the multiply. And those are all the same thing. The square root of 12 is the same as the square root of 2 times 6, which is the same as the square root of 2 times the square root of 6. Okay? Or I could do it like this. We could use all our options. Some people
4
said
times 3.
the square root of 12 times 1, right? So I could do that. So that's the square root of 12 times the square root of 1. Now that doesn't really help me simplify much, because I was asked to simplify the square root of 12, and my answer is the square root of 12 times the square root of 1. Right? So I didn't really simplify anything. All right, so our other option was the square root of 12 is equal to, what did you say, Sal?
Square root of 4 times
All right, square root of 4 times 3, which is equal to the square root of 4 times the square root of 3.
Which is equal to...
Wait! Can we do something further on this last one?
It's equal to
What do you
2
see there?
square root of 4 is...
What's that?
It's a perfect square.
What number times itself equals 4?
2.
2. So I could rewrite this as 2 square root of 3. Pretty cool. Pretty cool. Right? So we have simplified square root of 12 into 2 times the square root of 3. Now that I've explained that, I'm going to show you the important thing. The important thing, like we had all these possibilities, we tried all of them, and fortunately our last attempt was the right one, right? And hopefully you're not going to have to do all these other two. And I'm going to teach you how not to waste your time on doing 2 times 6 and 12 times 1, right? Because we wasted our time doing those. The only time, this is important, I'm going to write this down. The only way
Fun answer.
you can simplify
Just by exploding.
a radical is by finding a factor that is a perfect square. That's the only way. Otherwise, if it doesn't have a perfect square as a factor, you just wasted your, and then you don't go anywhere. It can't be simplified. Period. Okay. Does that make sense? Does everybody have that written down? I'm going to erase this part. Is that okay?
Yeah.
Since you guys are good at this. Okay.
So we get to do like equations.
So now we're going to do a couple. We have 2 minutes, right? 2.5 minutes? Here we go. Square root of 32. 32. Now, one thing I should add to this is you want the largest perfect square that goes into a number.
8 times 4.
Okay, so we have 8 times 4. Now my recommendation is you always write the perfect square first, right? So look, we have square root of 32 is the same as the square root of 4 times the square root of 8, right? I just left out that middle term, middle step. I just went straight to that. Everybody's with me on that?
Mm-hmm.
Yes? All right, so what's my final answer?
2 square root of 8.
So that equals 2 square root of 8, right?
You can simplify that more.
Oh my gosh, wait a minute, look at 8.
8 can be simplified into two square roots of, it can be 2 square roots of 4.
Yeah, look at that. So we started there, square root of 4 times the square root of 8, and we got 2 times the square root of 8. And then all of a sudden we thought, wait a minute, there's another perfect square in 8. What perfect square, which perfect square goes into 8? 4. Oh my God. So that means that could be written as 2 times the square root of 4 times the square root of 2, right? You with me? Ah, but what's the square root of 4?
2.
So what do I do with that 2 and this 2?
You multiply them.
They are multiplying times each other because there's nothing that says plus or minus, so it's just multiply. So if that's the square root of 4 is now 2, it's now that equals 2 times 2 times the square root of 2, which is equal to 4 times the square root of 2. You with me?
Yeah.
Everybody's with me?
I think so.
All right, now we wasted our time doing that because we didn't look for the largest perfect square in 32. Since we were able to take out 2 4s, what's 4 times 4?
8. No, 16.
4 times 4 is 16.
16,
16 times 2. So if we had thought right away, oh, 32 is 16 times 2, look how fast that would have been. Watch this. The square root of 32 is equal to the square root of 16 times the square root of 2, which is equal to 4 times the square root of 2. We got the same answer in one quick step.
Wow.
But it's okay. It's okay to do the long way if you really love doing the long, hard, laborious, sweatshop kind of way of doing things. That's okay with me, right? But there's a chance of making more mistakes. If the more steps you have, more mistakes, right? So if you start to look for the largest perfect squares, so what I'll do is I'll sometimes go through this and I won't go past, like 32, I wouldn't go past 30, I wouldn't go past 25 because that's 36. I know 36 doesn't go into, but I might say, okay, well I know 4 goes into 32. Does 9? No. Does 16?
Yes.
Oh my God, yes it does, right?
Oh my.
So that's how I would do that. Now what if I did this though? What if I said square root of, we'll do that one more.
9.
Square root of 24.
Oh, I should have done 21.
All right, square root of 24. Which of my perfect squares goes into 24?
6 and 4. 4.
It's got to be one of these. That's what you're going to start with. It's going to be 4, right? 4 times 6. So that's going to be the square root of 4 times the square root of 6, which is equal to 2 times the square root of 6. You're done. They're easy. You see what I'm saying? You got to make sense? What if I said this? Square root of
21.
200. Ooh, that'd be hard. I'll do something hard for you.
Oh.
Which of these goes into 200?
100.
100. Oh, well, let's try that. Square root of 100 times the square root of 2. That is equal to 10 times the square root of 2, right? Square root of 100 is 10. What number times itself equals 100? 10. 10 square root of 2. Fist of 5. You guys getting it?
Wow.
All right, good. Now, I'll do one more, and then we're done. What if I said the square root of 21? Which one of these perfect squares goes into 21?
None.
None. I can't simplify it anymore. That's as simple as it gets. I'm done. Okay? If you try to start with numbers other than these, you wasted your time. All right? All right, that's it. That is the lecture. You can have a very long break now.
Oh, good.
No, we have